once again introduce myself. I'm Morah Yonina, and I teach 2nd through 5th grade science to pure children at Yeshivat Noam. And we even have a 9-week period where I teach 1st grade science as well. This year, not only do we have a specialized science program for all of our elementary school students, but we also have a designated classroom in which your students join me once a week for 40 minutes where they are engaged and exposed to all different areas of scientific inquiry. My passion in life has always been to expose young minds to the wonders of the world and to scientific inquiry. I believe that children can grapple with the most sophisticated and complex scientific topics. Same units that we teach to high school students, college students, and beyond are those same topics that can be learned, appreciated, and understood by 2nd and 3rd graders. By incorporating student engagement, hands-on learning, a project-based experience, challenging our students to collaborate and investigate, challenging their minds, and encouraging them to stretch themselves beyond their comfortable limits, and by teaching them intriguing topics about the wonders of our world, we can teach our students to become independent thinkers and become independent thinkers. All this can be done at the same time while our students, as you can see, are having a lot of fun. The beauty of the scientific method is that the same steps that we are practicing and experiencing in grades 1 through 5 will be used by our students as a springboard for deep thought and critical inquiry throughout their entire lives. So my objective while teaching science to your children, in a phrase, is for these young minds to begin thinking like scientists. What we try to do is for our students to begin scientific inquiry in 2nd grade. And as Mrs. Stock just mentioned, each year we have our students build upon the skills that they acquired in the previous years. As they're going on from year to year, developing the process of scientific thought and scientific investigation, they are also learning critical topics in critical topics within science, including earth science, space science, life science, biology, physical science, and chemical science. So I'd like to take you all on a picture journey through my classroom and experience some of the units that your children have been experiencing along with me. The goal of our 2nd grade science program is to initiate our students to the concepts of making observations, asking questions, forming hypotheses, and the excitement of performing an experiment. During the weeks of Rosh Hashanah, our 2nd graders were observing honey and comparing its properties to that of other liquids. As we began to understand the concept of viscosity, our students went on to make observations and design their own experiment within the classroom to test the viscosity in all the liquids. In this particular class, the students designed an experiment in which they filled styrofoam cups all to the same level with each of the various liquids that they were analyzing. This class decided to take a skewer and to punch a hole simultaneously into the cups and to observe the liquid and its viscosity as the cups began to empty out. They experienced the excitement of designing their own experiment. Each 2nd grade class, after making observations and forming hypotheses, designed their own way to discover viscosity in liquids such as honey, oil, water, jelly, anything they found in our science classroom. In another unit in 2nd grade, our students began to investigate the concept of work and different things that they can do to minimize the amount of work that they need to do in order to get a job done. They noticed that throughout our classroom, even in their homes and throughout our school, we have simple machines that we are using at all times. After investigating what the function is of each of the simple machines, levers, pulleys, screws, wedges, wheel and axle, our students were challenged to use those machines to accomplish a task. They had to accomplish the task with the machine and without the machine, and compare the amounts of work and effort that they needed to do in order to accomplish that goal. One example would be to lift a heavy load or to lift their teacher without touching her. And they had to figure out that by putting together a lever with a fulcrum and a board, by creating a seesaw in the classroom, they were able to lift someone else without touching them. After the excitement of investigating the 6 simple machines, our students worked very hard to build and design their own simple machines. From marshmallow catapult lever launchers to Archimedes screws that they used to lift water from one location to the next. Some of them got creative and turned them into straws, drinking straws, to wheel and axle race cars that they raced down different inclined planes, and a functioning flagpole pulley. It was a very exciting time, mostly because they got to bring all their machines home in their special simple machine tote. As we move on to 3rd grade, we begin to challenge our students to feel more comfortable making observations and forming hypotheses. As they get to 3rd grade, they need to record their data in their journal and compare their data to students in the other class. In addition, in 3rd grade, we have an overarching theme of molecules, which is a complex unit that they'll be learning throughout their entire scientific lives, and they learn about how the form and the function of molecules affect everything that molecules do. So in a unit on photosynthesis in the beginning of the year, our students began to notice the changing of the leaves, and the colors have gone from green to red, orange, and yellow. After beginning to understand the complexity of the process of photosynthesis and how green chlorophyll molecules are working all summer long to produce food for the tree, they begin to dye and expose the other colors, the carotenoids and the anthocyanins. Our 3rd graders formed hypotheses. If they can extract pigments from markers and separate those pigments based on their molecular size by using a type of paper called chromatography paper with microscopic holes that can separate different size marker pigments, then they could use that same exact method to extract pigments from green leaves. And if they can extract those pigments from green leaves, they can test to see if their learning was correct. Are there really hidden pigments underneath the green chlorophyll molecules? Our students were excited as they observed, hypothesized, and recorded all of their data throughout the entire process. Throughout the year, our students will be focusing on all different types of molecules in 3rd grade, whether it be water molecules to learn all their properties, oil molecules, soap molecules, matter molecules, and how the molecules move. It is definitely a year filled of inquiry and investigation. As we move on to 4th grade, our goal is to introduce our students to the formal world of scientific inquiry using the scientific method. I see there are a lot of members in this classroom that have Noam members who have helped reinforce the steps of the scientific method for our students, from making observations to taking notes, asking questions, forming hypotheses, making predictions, designing experiments with controls and variables, and thank you, Rebbe Beer, for showing us the importance of analyzing data before coming up with their own conclusion. In addition, our students begin to expand their understanding and knowledge of critical scientific topics with project-based learning throughout the year. An example of this is during the Parsha with the story of Migdal Bavel. Our students researched different towers, the tallest towers that in the world, and they analyzed the structures of those towers. After doing research about those towers, they went on to design their own, once again, marshmallow and spaghetti towers, and were challenged to build towers that would be as tall as themselves and strong enough, with a strong enough structure that they could move from one table to the next. If their tower collapsed before the end of the period, they were challenged to go back to the drawing board and start from the beginning, collaborating and continuing their design. In 4th grade, the theme, the unit that they focus on throughout the year is on energy, atoms, and electrons. And what they focus on is how electrons move to create all different types of energy, including static electricity, magnetism, and they're currently working to construct and build and understand circuits. So our students will be using all of their understandings of electrons to build fruit circuits, battery circuits, and continue their learning by figuring out how to use greener energy in their studies. We want our students to leave 5th grade by mastering the steps of the scientific method with the ability to design their own experiments and to be able to incorporate their own controls and variables in their scientific design. Over here you just see an example of some 5th grade students who are working with best bugs. They are about 2-inch long beetles that have schlepping power. They're able to carry many times their weight. After forming hypotheses about how many paper clips the best bugs can carry across the table by making a lasso belt in between their thorax and abdomen, our students went on to compare the ability of each of their best bugs. As you can see, one student made a fascinating observation that his best bug was unable to have the same carrying capacity as his neighbors because his was missing a leg. Others measured the length of their best bug's legs and came up with conclusions as to why one best bug would be stronger than the next. Throughout the year, our students focus on the nature of light, NASA and launching a shuttle, and with an in-depth investigation on microorganisms and cells. Currently, we've been doing a lot of learning in the dark as we learn about the nature of light. When we learn about a property, our students come into the classroom and they are faced with multiple supplies. After learning about that property, they are challenged to either prove or disprove that idea with the supplies in front of them. So here you see students trying to prove that light travels in a straight line, seeing if they can get lasers to transmit, absorb, or reflect light, analyzing the property of wavelengths of different colors of light, and one of my personal favorites, they were given 3 miniature light bulbs, red, green, and blue, which are the primary colors of light, and they are challenged to create the secondary colors, yellow, magenta, and cyan, and white light, which the students did an amazing job demonstrating. So, in conclusion, the goal of the science program, the elementary science program at Yeshivat Noam, is to encourage our students to be lifelong learners, to teach them about the importance of inquiry and investigation and how to apply that and those skills to all areas of life. If there's time, I would love to go through a little example with you. If not, I'm more than happy to take questions.
I can do both.
So, I guess I'll start off with a little investigation. So, we're in 3rd grade right now, and in front of you, you have something called a pipette. And if you pick up your pipette, you can release the air, and we can use air pressure to lift the water. So I'd like everyone to squeeze their pipette, keep it squeezed at the bulb at the top, dip it into your water, do not let go until I say, 1, 2, 3, let go. Release your hand. You can now lift your pipette and your pipette will be filled with water. Okay, no one's dripping? Great. Can you please form a hypothesis? How many drops of H2O do you think you can place on a penny without the water spilling over the surface of the penny? Yes. I think 5. 5. Write that down. You think? I'll give you heads. 5. Do you think heads and tails would have the same amount?
I'm not sure.
Okay.
Maybe.
That's fine.
I'm not willing to commit.
Does anyone think that there's more or less drops of penny on the water on the surface of the penny? More on heads. How many do you think this is that? You're going with 10, and I think I heard my head was 8 too. So we've got 2 and we've got 10. So everyone keep in mind your hypothesis, and I'd like to challenge you all to do the following. Before we get to our penny, just practice one time, dropping single drops of water. 1, 2, 3, 4. Okay? Let's go for it. It'll begin.
Heads or tails?
Heads. Let's all do heads. Remember, you're adding water until the water spills over the surface of the pen. Miss Usher, Miss Levesky, you're out.
That's
Okay.
so unexpected.
28.
I heard an answer already. We have 28 over here. We have an unexpected. I could take a picture of that one. So some of you are observing this phenomenon more than others. But are you noticing that there is a bubble on the surface of your pen?
Oh my God. That's crazy.
Please try it one more time on tails.
That's so super cool.
Anyone get more than 35?
Okay, that's 25.
This is Hal, the teacher in 3rd grade. She is a professional nail painter, and her skill has enabled her to get 60 drops of H2O.
No.
Because her hands are so steady.
I don't even know what I'm passing.
Anyone beat their record?
28.
We would probably have to try this multiple times. Every student would write down their hypothesis, try out head 3 times, try out tails 3 times.
21 too.
So that's 21. 21.
Yeah,
So what could be a reason why you had a different number of drops from both of your
Because of the configuration on the penny.
okay, so one reason could be definitely the configuration. Is there anything else different between the front and the back of your pen?
Is it more concave, the one with the head?
That's an excellent observation. I never noticed that myself. One thing that I did notice is that if you go to the bank right over here, my Yeshivat Noam, they will give you a beautiful brand new penny.
Oh,
But if you go to a bank, warranty net, your pennies will not be clean. So when you're trying this out,
start wondering why
charge you about that.
this would be part of a unit where our students are learning about the properties of water, including cohesion. They will go on to discover that cohesion, where water molecules stick together, are happening in all different areas of their life. Can you think of a time or an incident where you've seen water molecules stick closely together?
Pour your drink just a little too high.
When you pour your drink just a little bit too high, you'll see that water will go above the brim of the cup. How about if you're a 3rd grader, you will inevitably raise your hand and say, when I spill water on my Shabbos tablecloth, I notice that my water molecules bead. Or if you look out your window, you will see that water molecules will fall together and connect to each other. Or if you look outside after a rainstorm, you'll see that water molecules on a leaf will also form beads. Water molecules, because of its structure, which our students will know about, does something called cohesion, where they stick together, and surface tension, where they form a tight surface as they're exposed to air. Our students will go on to investigate this by adding soap to break surface tension and build upon this idea as we learn about the molecules. So with that, I'd love to take some questions. Feel free to go through the curriculum. It'll give you a little bit of a taste of what we learn about, the units of exploration, some of the experiments that we do to reinforce those concepts.
Question.
When is the 1st grade? You said there was a 9th.
First grade is actually starting tomorrow. And we're going to be working together for 9 weeks.